So welcome to the video. So today we'll try to solve this particular question from codeforces website. The question code is 1725A for those who want to know the question code. So the question says that we have a grid, like something like this, right? Okay. So in the grid we will be given two inputs, two integers as input, 3 and 4. Let us say for this example. So 3, the first integer represents the number of rows in that grid, and the second integer represents the number of columns in that grid. Okay. So for this input we are given 3 and 4. So the grid appears something like this, and the first element will be in the first row will be 1, and the second element will be 2, and so on and so forth, right? So we'll have to define a thing called domino here, right? Domino is the joint between any two grid elements. So this is one domino, like see this two grid element pair is a domino, right? 1 and 2, this is a domino, this is a domino, and 2 3 is a domino, 5 6 is a domino, 1 5 is a domino, 2 6 is a domino, and so on and so forth, right? Okay. So for a particular domino, if let us say for this specific highlighted domino, the difference between the elements is 1, right? Exactly 1. So we can say that this is a tight domino, right? This is an example. So as you can see in this example, 1 2 will be a tight domino, 2 3 will be a tight domino, 3 4 and 5 6 6 7 7 8 9 10 10 11 and 11 12. Total 9 tight dominoes are present, which is the output, right? Which is what we have to output, right? In case let us take this example, right? 2 and 1. I've already drawn this. So 2 and 1 will look like this, right? There are 2 rows and only 1 column, right? So it will look something like this. So there is only one domino present, which is tight, right? Because the difference is exactly 1. So we'll have to output 1, which is the expected output here, right? So if you see this example, right, the tight domino ka logic follows this specific condition, right? If let us just say the case where the number of columns is only 1, that will be different, we'll be treating that different, and where the number of columns is greater than 1, we will be treating that different. Okay. This will be the case where columns are great, number of columns is greater than 1, right? So for this case you can see because the numbering happens from left to right at each row, and then we go to the next row, so only the elements in a particular row, right, adjacent elements in a particular row, only they can have a difference of 1, right? In this case these two have a difference of 1, so there is one tight domino in the first row and one tight domino in the second row. In total we have 2, right? If we keep increasing the number of columns, right, there are 2 tight dominoes in the first row, 2 tight dominoes in the second row, right? As you can see here, number of columns is 3, right? As you can see, for each row we are getting n minus 1, where n is the number of m is the number of columns according to the question. So m minus 1 tight dominoes we are getting for each row, and we have n such rows, right? So the formula here will be number of rows times number of columns minus 1. This will give us the number of tight dominoes where the number of columns is greater than 1. So what will this be when the number of columns is exactly 1, right? So this will be the case, right? As you can see, if there is only one element in a particular row, then the next element will have to go to the next row, right? So as you can see in this first example, there is only 2 elements, 1 and 2, so there is only one domino formed, right? Similarly here, if we increase one more number, that is 3 rows and 1 column, then we'll have 2 two tight dominoes. Between 1 2 there is one tight domino, and between 2 and 3 there is one tight domino. So total is 2, right? So what will this be here? If columns greater than 1, right? Now equal to 1, then this will be number of rows minus 1 will be the number of tight dominoes, right? Yeah, minus 1, right? This will be the answer. This will also check for the case where the number of columns is also 1, right? There is only one element, so there are no dominoes, so number of rows minus 1 will be 0 in this case. So this handles the edge case also, right? Let us try and write the code for this example, right? Okay, I am copying this input. Yeah, and reading the input string. Okay. Num rows, comma, num calls equal to okay. Input string, and just take this input. This will be equal to input string called eval. Now split that and 0. Num columns equal to input string not split 1, right? You can print and see if they are getting the correct values. Right, here. So what we'll do is, if one columns is greater than 1, then what we'll do, print num rows star num calls minus 1. Okay, else print rows minus 1, right? Let's show this part in this code. This should run fine. Okay, string, acha, we'll have to eval this. To do that eval of this, basically converting that into integer. Right, we'll take this input, which is correct. 3 4 ka we are expecting 9, right? 2 1 ka we are expecting 1, and right, if we say 4 by 4, that should give us 12, right? Similarly, 1 by 1, and it should be 0. It is 100 by 100, then it should be 9900. Seems fair. Let us try and submit the solution. Accepted, right? So I'm just giving you a go through of the code again. We are just reading the inputs. We are reading the number of rows here, number of columns here. If the number of columns is greater than 1, then we'll be outputting number of rows times number of columns minus 1, right? And if it is equal to 1, then we'll just output the number of rows minus 1 as the number of write down rows. As you can see, the test case is passed for all the possible values, right? Cool, huh? Thank you, and that's it for today. We'll meet you guys tomorrow. Okay? Bye.